Hello and welcome. Today we are here to cover the basics of soil acidity. Most people know about acid rain and many weather effects that are bad for the environment. Soil acidity goes more in depth into what is happening with our soil and the life connected to it. Not only will we be looking at the basics of soil acidity, but also how to find the amount of acidity in the soil. Another thing that we cover for the science of soil is the hazards of soil acidity. Now let's jump right into the learning experience. What is soil acidity? Soil acidity is a condition in which the soil pH is lower than a neutral pH. To go more in depth, it is a massive variable that affects a wide range of soil chemical and biological properties. This chemical variable influences the likelihood that plant roots will take up both nutrient and toxic elements. It also determines what soil is good for growing certain plants and which is not suitable for growing them. To test soil, we first need to know what we can use to determine the acidity of soil. And what better way to find it? By using the pH scale shown here. It goes from 0 to 7 pH. Normally it would go to 14 by having alkalinity included. Instead, we are only using the acidity side of the scale to find the soil pH. There are also the pH strips with the color levels on there. That changes whenever it is dipped into a solution, say for instance soil mixed in water. There are also the pH strips with the color levels on there. That changes whenever it is dipped into a solution, say for instance soil mixed in water. As you can see here is an example of pH strip being used to determine a soil acidity. That can be annoying to use, especially if the lighting isn't good. There is another tool that can be used to determine the acidity of soil. That tool is a potentiometric method, which is the most accurate method of determining the soil pH. How this device works is it uses pH-sensitive glass electrode and a standard reference electrode, or simply a probe that combines both as one. This is the other half of the potentiometric device being used here. The pH electrode is inserted into one of the samples being tested. The difference between the hydrogen ion activities in the soil suspension and in the glass electrode gives rise to the electrometric potential that is related to the soil solution pH. So what happens here is the pH gets reported back to the device shown earlier. It does take time for the pH readings to stop rising or falling on the screen. Once it does stop, you have your data for the soil acidity. How are we affecting the acidity of soil? The natural processes of soil acidification is usually inadvertently accelerated by human activities. The use of nitrogen fertilizers is part of the problem. It may be helped with global food supplies staying ahead of the increasing population, but it has accelerated acidification of the world's cropland soils. Most of these involve the acts of agricultural farming. How does the acidity of soil affect life? The pH of the soil solution exerts a critical influence on all the plants, animals, and microbes that live in the soil. To non-adapted plants, strongly acid soil presents a host of problems. These problems include toxicity of aluminum, manganese, and hydrogen, as well as deficiencies of calcium, magnesium, molybdenum, and phosphorus. A lot of things require a certain balance, even the soil beneath our very feet. Before we wrap things up, let's review what we learned during this session. We learned that soil acidity is a key part of soil science, a variable that controls the chemical and biological behavior of the soil. The many tools needed to find the pH of soil, how human activities cause soil acidity to be unbalanced, most of them being connected to agricultural farming. Lastly, we also learned soil acidity has a critical influence on the different types of plants, animals, and microbes that live and use the soil. Well, I think that's everything for this lecture. Thanks for joining me on this learning topic, and have a nice day.